Chapter 10, Systems Architecture. Chapter Objectives. Provide a checklist of issues to consider when selecting a system architecture. Trace the evolution of system architecture from mainframes to current systems and designs. Explain client-server architecture including tiers, cost-benefit issues, and performance. Compare in-house e-commerce development with prepackaged solutions is what that probably should say. Discuss the impact of cloud computing. Define network topology, including hierarchical, bus, ring, star, and mesh topologies. Describe wireless networking, including wireless standards, topologies, and trends. Describe the system design specification. Architecture checklist, Corporate organization and culture. Certain organizations may have certain types of architecture that they will only use, for example. I know that in certain companies they've stuck with token ring longer than they should have because that was part of their organization. Enterprise resource planning, so from the ERP process. Initial and total cost of ownership, so those are two separate things, we'll go into that. Scalability, web integration, legacy system interface requirements. A lot of these legacy systems are old mainframe COBOL type systems, believe it or not, even still. Processing options, security issues, and corporate portals. So let's continue going through this in some detail. Corporate organization and culture. An information system must perform well in a company's organization and culture. So if a company's information technology department is highly versed with a Windows platform, you probably don't want to go introduce a Linux system there. That sort of thing is what they're talking about. For the ERP process, establish a company-wide strategy for using IT that includes a specific architecture, standards for data, processing network, and user interface design. Now let's break down initial cost and total cost of ownership. So total cost of ownership includes tangible purchase fees and contracts. These are known as hard costs. The initial cost is just the initial setup cost. Scalability. A system's ability to expand, change, or downsize easily to meet the organization's changing needs of a business enterprise. So if you have a network architecture where you have, say, a web server farm where you have a lot of web servers to service your business, you may want to remove or add web servers easily to a configuration based on the size of the company. So for example, I'm sure Amazon, for example, introduces a whole lot of new web servers this time of year because it's Christmas and they get more busy. And they might shut these systems down or even outright remove them after the Christmas holiday is over. Web integration. Will the application be part of an e-commerce strategy, and what is the degree of integration with other web-based components? Legacy systems. A new system might have to interface with one or more legacy systems, which are older systems that use outdated technology but are still functional. And this is where I went into the COBOL mainframe example. Processing options. Will the system process data online or in batches? So in other words, will it process the data as it receives it, or will it batch it up and run jobs overnight to do mass updates? Security issues. Security threats and defenses are major concerns to a systems analyst. So this is a really big deal in industries such as banking and finance. Corporate portals provide access for customers, employees, suppliers, and the public. A well-designed portal can integrate with various other systems and provide a consistent look and feel. Continuing on, every business information system must carry out three main functions. They are: manage applications that perform the processing logic, handle data storage and access, and provide an interface. Mainframe architecture. This is a then and now presentation. So if you look at this diagram, you've had the mainframe computer, which handled all of the processing, and at a workstation or somebody's desk, you wouldn't have a computer, you would have a terminal, which was really just a monitor and a keyboard that plugged in through a serial connection, usually, to the mainframe computer. So without the mainframe in the background, these terminals were completely useless and couldn't do anything for themselves, and thus these terminals received the nickname dumb terminals. That's no joke. Like the IBM 3260 dumb terminal was just that, just a screen and a keyboard. So in a mainframe architecture, the server handles everything: the data, the processing, services, and the support for one or more computers. So everything was taken care of on the mainframe. Then came the personal computer, which was the standalone computer, and computers could run their own processes, and most of these processes were really which is really like spreadsheet, word processing, database, without assistance from an IT group. So really, these standalone computers in the very early days took on the features that Microsoft Office does now. Companies linked the standalone computers into networks that used clients to exchange data and perform local processing. So in these early machines, you would have what was called the thick client interface, where there was actually a program that ran on your computer, on your local computer or your standalone computer, that actually handled some of the processing and retrieved and manipulated data and processes that existed on the server. Then, with the network evolution, we started to have a lot more LANs and WANs out there rather than the standalone computers. And once this came to be, then networking came about. And during this period, you would see more the transition from the thick client to the thin client applications, which, those are your browser-based applications that you see nowadays. We're going to go through a little bit more of that right now. This is some client-server architecture, and it generally refers to systems that divide processing between one or more networked clients and a central server. The client handles the entire user interface, including data entry, data query, and screen presentation logic. The server stores the data and the processes and provides data access and database management functions. So here on this next chart, we're going to go through what I've kind of been discussing already. So here are some comparisons. I'm not going to read all this over because it'll get confusing, but I will stop for a second and let you look it over for yourselves. The client's role. A client-server relationship must specify how the processing will be divided between the client and the server. Here, I was talking about the thick client. This book calls it a fat client. It's where the design locates all or most of the application logic on the client itself. So that's, like I said, where a program exists on the client machine that handles a lot of the processing. A thin client, on the other hand, can provide better performance because there's a lot less data being transferred. And think of your thin client applications are really applications that run inside your browsers. So here I'm going to take a minute again for you to look this over, and you can do some comparisons between thick client and thin client, or fat client and thin client. However you want to look at it, either way is fine with me. I'll know what you mean. Continuing on, let's look at client-server tiers. In a two-tier design, the user interface resides on the client. All data resides on the server, and the application logic can run either on the server or on the client, or it can be divided. In a three-tier design, the user interface runs on the client. The data is stored on the server, but the middle layer between the client server processes the client requests and translates them into data commands. So really the easiest way, that seems a little bit complex to me. So really in a two-tier design, you've got a user interface which resides on the client, and you have an application and database that are tied together on one machine. In a three-tier design, your application and your database are separated, and that's your third layer, or third tier, excuse me. So here's an example of what I'm talking about right here. You can see on a three-tier, they simply separate the database server with the application server. Now let's go back into middleware again. Middleware offers software and middleware legacy systems and so like I said, the middle piece that makes one system talk to the other. And it can be called glue that holds systems and applications together. Middleware represents the slash in terms of client server. Middleware resembles the plumbing system in your home in that it connects important objects in a way that requires little attention. Here's some examples. Again, I'll give you a second to look this over. Make sure you understand this. All right, let's continue on by discussing cost-benefit issues. To support business requirements, information systems need to be scalable, powerful, and flexible. For most companies, client-server systems offer the best combination of features to meet those needs. Client-server applications usually can transfer server information rather quickly. It's a newer concept, where mainframes usually have to be totally replaced, which means that the information has to be pulled off them and then put onto a new mainframe. This can be a very huge process. As far as performance issues, IBM states that the performance characteristics of a client-server system are not the same as a processing environment. Client-server response times increase gradually as more requests are made, but then rise dramatically when the system nears its capacity. This is called the knee of the curve because it marks a sharp decline in the system's speed and efficiency. So really what this looks like is a bell curve right here. The impact of the Internet. An Internet-based architecture, in addition to data and application logic, is the entire user interface is provided by the web server in the form of HTML documents that are displayed by the client's browser. Shifting the responsibility for the interface from the client to the server simplifies data transmission and results in a lower hardware cost and complexity. Pretty straightforward. So when we talk about cloud computing, that refers to the cloud symbol that is used to represent the Internet. The cloud computing concepts envision a cloud of remote computers that provide total online software and data environments that can be hosted by third parties. Cloud computing requires significantly more bandwidth. The amount of data transferred can be a fixed time period or rather than a traditional client-server network. Web 2.0. It's not a reference to a more technically advanced version of the current web. It envisions a second generation of the web that will enable people to collaborate, interact, and share information more dynamically. Applications will deliver software as a continuous service with no limitations on the number of users that can connect or how users can consume, modify, or exchange data. The goal is to enhance creativity, interaction, and the sharing of ideas. Let's now go over in-house solutions, a unique website with a look and feel consistent with the company's other marketing efforts. Complete control over the organization of the site, the number of pages, and the size of the files. A scalable structure to handle increases in sales and product offerings in the future. More flexibility to modify and manage the site as the company changes. The opportunity to integrate the firm's web-based systems with its other information systems, creating a potential for more savings and better customer service. Take a minute and look this over, please. Continuing on with package solutions. Many vendors, including Microsoft and Intershop, offer turnkey systems for companies that want to get an e-business up and running quickly. So these are pre-packaged options. They come from vendors. You can buy them. Usually they give you some customization options and a configuration screen where you can brand it, make it look like your own. Service providers. Many ASPs, or application service providers, offer full-scale internet business services for companies that decide to outsource those functions. Take a look at this example here with the ATM query process. Notice the notation. So batch processing, still with us after all these years. Sometimes it makes sense to use batch processing. Sometimes a batch can be run at an off time where it isn't going to have as much impact. Let's go over some of the bullet points and then we'll discuss it. So batch processing means that data is managed in groups or batches. An acceptable choice in the 1960s, and for most firms, it was the only choice in the 1960s. So tasks can be planned and run on predetermined schedules without user involvement. Batch programs that require major network resource can be run at times when costs and impact on other traffic will be the lowest. A batch method is well suited to address security, audit, and privacy concerns because it's a controlled system. It runs as one job usually. So usually you'll have like a batch file or a batch script that comes in that'll read a file. So let's take an ATM as an example here, since we've just had the previous slide with an ATM on it. So an ATM transaction can be processed immediately and have the calculations done on the system during the day and throughout the country. So let's say you bank at Citizens Bank, and it's a regional New England bank for the most part. So at 10 o'clock on a Friday morning when everyone's gotten paid, people might be hitting that ATM system really, really hard, and it might queue up a lot of transactions that need to get processed, and it might affect the response time. Nowadays that's not an issue, but hypothetically that could happen. Now if it's a batch process, you could just collect that ATM transaction information, say yes, this is okay to go through, do some if-then calculations on the spot, but then batch it and run it overnight to update your bank account and what have you. That's an example of batch processing. So here's a point of sale terminal, which I'll give you a second to look over. And this will give you an idea as to what I was trying to describe with the ATM. And you can see how the accounting system is batched up overnight, whereas the point of sale system affects the inventory immediately. The OSI model, this is the Open Systems Interconnection model, and it describes how data moves from an application on one computer to an application on another networked computer. It provides a physical design standard that assures seamless network connectivity regardless of specific hardware environment. I teach CIS-276. The first part of this class focuses exclusively on the OSI model, or its condensed version known as the network model. Network topology can refer to a physical or logical view of the network. Physical topology describes the actual network cabling and connections, and the logical topology describes the way the components interact. A hierarchical network has departmental servers, and it controls lower levels of processing in network devices. A bus network is also referred to as a backbone network because it has a central bus cable that data can travel upon. A ring network is still around, and it's just what it says. It's a big ring where the computers are all tied in a big circle. A star network is the most popular network. It has a central networking device called a switch, which everything plugs into that. And then a mesh network is where every node connects to every other node. And there's different levels of mesh networks. There's half mesh, there's full mesh, and what have you. So that's a little beyond the scope of this class, but something to understand. And what I'd like to do right now is I would like to bring up the layers in the OSI model, just so you'll have it really quick, because it is important, and it looks like I'm going right to Wikipedia to get that. So if you look here, these are the different layers, and I'll go through them. There's the physical layer. This is really just what it says. It's the physical layer, it's the cables, it's the computers, and that sort of thing. So the data link layer is also known as the switching layer, and it's where your switches operate and data is transferred based on your different MAC addresses and what have you. So your network layer and your transport layer work together. This is also known as the TCP IP layer. So this is how actually it's TCP and then IP. So those layers together, that's where you think of your IP addressing, IPv4, IPv6. That happens at these layers where the data is actually transferred. Then you have the session layer, which is the layer where you have everything that is involved with your connection. That is the actual connection, that is the session that's created. The presentation layer is the OS. So in this case, I'm using a Windows computer, and I'm using Windows 10 graphical user environment, so that's what my presentation layer is. My application layer is the application in which I'm currently using, and right now I'm using a web browser, and that is my application here. So lots of good information, and like I said, I'm going way beyond the scope of this class with the OSI model, but I wanted to bring that up really quick because it is important. So now I've gone through the different ring networks, star networks, and mesh networks, and like I said, there's different levels of mesh networks, so keep that in mind as well. But I'm going to clip through these next few slides quietly and let you study this yourself. Read the book if you have any questions, or feel free to ask. Remember here I said the bus network, I would also accept it if you called it a backbone network. In this diagram you can see why it gets that name. And here when we look at the mesh diagram, let's say this connection we're missing, or this connection here was missing. That would be known as a partial mesh network. And there's all different levels of partial mesh which exist. Continuing on our network devices discussion, let's talk about network devices such as local area networks, wide area networks. These can be connected with devices known as routers. So a router is a device that connects network segments and determines the most efficient path and guides the flow of data. So with a router, if one route can't work, there's a possibility that another one can, which is what makes the internet so flexible. So we can use various modeling tools to design logical views of networks, and they have drawing tools with little items that look like the physical structures that you're drawing. Microsoft Visio is a really big name here. There's also a little product called Glyphy, which I'm familiar with, which I use. So let's talk about wireless networks. So the most popular, and it's a de jure standard because it's set up by the Institute of Electrical and Electronics Engineers. So it is a de jure standard. It's a family of standards developed by the Institute of Electrical and Electronical Engineers, like I said, for wireless LANs. I'm not going to go into the subletters here because this is an old text and these slides might be out of date here. So again, they're right here. This information is accurate, but it's probably not up to date, so I'm going to skip past that as well. Additionally, I'm going to keep skipping through the network stuff here, the wireless network stuff. I want you to look it over, but know that it might be a little bit out of date here. Now we're going to discuss system design completion. System architecture marks the end of the system design phase of the SDLC. Final activities in the system design phase are preparing a system design specification, obtaining user approval, delivering a presentation to management. So with the design specification, it's a document that presents the complex and complete design for the new information system, along with detailed costs, staffing, scheduling for completing the next SDLC phase, systems implementation. A typical system design specification typically includes the following sections: a management summary, the system components, and the system environment. The book in this slide itself goes through a little bit more detail on that, so please look that over carefully. Implementation requirements. It's going to include time and cost estimates and additional material. Again, make sure you understand this clearly and well. It's in the textbook. User approval. Users must review and approve the interface, design, report, and menu designs, data entry screens, source documents, and other areas of this system that can affect them. Ensures that you do not have a major task of obtaining approvals at the end. Keeps the user involved with the system's development. Gives you feedback about whether or not you are on target. And lastly is the presentation. This gives you an opportunity to explain the system, answer questions, obtain your final signatures. The first presentation is going to be a technically oriented conversation because you're going to be dealing with the technical people who are going to get this started and get things moving. The next will be to managers, and the final presentation is going to be to the management. Chapter summary. An information system combines hardware, software, data, procedures, and people into a system architecture. Before selecting an architecture, the analyst must consider enterprise resource planning, initial cost, and total cost of ownership, scalability, web integration, legacy interface requirements, processing options, security issues, and corporate portals. ERP establishes an enterprise-wide strategy for IT resources and specific standards for data processing, network, and user interface design. An architecture requires servers and clients. Servers are computers that supply data. Processing services or others support one or more computers called clients. Client-server architecture divides processing between one or more clients and a central server. A thick client design places most or all of the application processing logic on the client itself. A thin client places most of it on the server. Client-server designs can be a 2-tier design or a 3-tier design. Remember, the 3-tier design has a separate database system and application system. The internet has had an enormous impact on system architecture. The most prevalent processing method today is online processing. Networks allow the sharing of hardware, software, and data resources in order to reduce expenses and provide more capability to users. The way a network is configured is called the network topology, and remember my discussion on network topology involving mesh and full mesh and partial mesh, because that will be your forum question. The complete design specification presents the complete systems design for an information system and is the basis for the presentation that completes the system design phase. Thank you.